All right, guys. So what I mentioned, I'm going to now show you how you can validate whether the result you are getting from the recursion is correct. There's a way how you can, implement the same logic without recursion, and that's what we call the looping. Because if you look at the recursion, in recursion, we're calling the function again and again, but obviously with the different set of parameters, and based on the condition in our function, the function behave differently. The same way we can do it in the looping, that in the loop we can perform the same action, but obviously that's going to be a bit different way to do the programming. All right, so I'm just going to again call summation loop, right? And I'm just going to now, in this here, I'm just going to pass one variable, and you're gonna see, like I mentioned last time, I'm going to say value in range of num, because range will give me the iterator that I can iterate, and it start from 1. So what I'm going to do now, oops, what happened? Oh, good, yeah. So what I'm going to do now, result is equal to 0, and all I'm going to do now, result is equal to result plus value, right? And pretty simple logic. It's going to actually start from 1 all the way towards the last value that we have, and it's going to add that result into the result variable, and at the end we're just going to return result, right? It's pretty straightforward. Sorry, what I'm putting. And now let me quickly show you the same logic which we have put above, but this time instead of, I'm not going to do some, all I'm going to do summation loop, and it's going to be 1000, right? So I just want to see what my sum is going to look like, and I'm going to say it's going to be summation loop. Right, same solution, but in a different way, but it's going to produce the same output. So now these two outputs should remain same, right? That's the test that we are trying to do. So let's run it and see whether it's going to work for us or not. So you can see we are getting summation loop 499500. I believe it's going to start from, let me see. I think it's not adding the last value because they start from 0. How about if I just do, I just want to print for a testing purpose, I just need to check one thing, and then we will see. So print, and then so that's the way we start debugging. I just want to print the value, what my initial value is going to be, and I'm just going to break it because it looks like it's not starting from 1, it is starting from 0, and it is going all the way upper bound -1, right? So we'll just confirm it. Let's see. Yeah, so my doubt was clear. It was true. It's starting from 1. So it's the logic is going to be pretty smooth. What we're gonna do, once we add into my result, because we are starting from index 0. So all we need to do is just add 1 into the value, because that will actually increment in the index, and now we are going to get whatever value which is truly required into my range, right? So now I don't need that. I can take this one out. I can take this one out. Yeah. And now if I run it now, we're gonna see. Yeah. So both values are matching. So you can see we implement, we override the limitation of the Python by just splitting my recursion into two different calls, and based on the values, it's going to actually execute it, and then it will return us the result. There's another way, because now you can see it's going to execute these two sequentially. It will execute one and then it will move up, but through the threading we can do them in parallel, which obviously fasten the execution, right? Or even we can call the recursion in the loop, right? So in order to just limit it. So there are multiple techniques that we can use to even further refine it. But the good thing, like I mentioned, in Python, a lot of things are pre-optimized, so you don't need to put that effort, because if you are using the existing functionality, that means you are already using the pre-optimized the work, right? The only time when you need the optimization at your end, once you are building a completely new library or solution by yourself that requires some optimization. So that's how you actually control the recursion, or to just break the recursion using the looping concept. If you want to find out what the best way to not use the recursion, so that's the solution. Feel free to reach out if you have any comments or question about recursion or looping. More than happy to answer. Otherwise, thanks for watching, and stay tuned for the next videos in Python video series.